Hello everyone, this is Ashish. Just good to be here and present at the first data orchestration conference. I would like to present some interesting use cases for which we have been using Alluxio with Presto, and we're able to solve some data analytics, interactive and ad hoc query solutions at WalmartLabs. So as the agenda will go, Initially, we'll probably try to lay out what the problem statement was, why we were even looking for an analytical solution despite our all existing stores, why there was a dire need to have a solution which can do a federated query and do a level of data orchestration as we were embarking into a cloud journey, hybrid and a multi-cloud journey. Then I'll probably try to give an overview of a high-level architecture, how we kicked off this initial stack, which was solving most of the problem, and how that stack got evolved when we get involved in a hybrid cloud situation. So we'll try to cover an architectural component. We'll try to give a sense of how we leverages these two technologies, and wherein at the other places to make it as an enterprise offering. We have to build certain ecosystem projects internally to make this a managed query service. So to begin with, what I've seen in Walmart, and it's same is the case for any larger enterprises. So there are data is usually residing in a lot of different diverse sources, and the reason being there are no one-stop solution which can cater to all the different analytical or data query workloads. So there are systems such as Teradata, which is good for ultra-low latency queries. There are systems such as SAP HANA. I've pretty much seen every database and SQL, NoSQL technology which exists today, which been widely used at Walmart. So this is just a smaller snapshot. And there has been, every such technology has its own rationale to use that. So there are teams which largely use Druid clusters for a time series analysis. So every bit of thing has its own use case, and we saw that there's no one-stop solution, and we don't want to solve that problem as team, and their use cases has a different needs to leverage these technologies. We wanted to ensure that this is how this piece is going to be. And even the cloud coming into a picture, most of the workloads are moving into object stores and the different stores. There were a lot of initiatives as part of data lake offering to ensure that, let's say, all of the stores are good, which they're serving a purpose to powering different applications. But when it was becoming very cumbersome for any analyst to do analyze all of this data, so one of the initiative was having a large enough data lake cluster, which was supposed to act as a data hub. So where all the data from this different diverse sources will get sourced into this data lake cluster. So which was working good. So it's been, I think, more than 3-4 years at Walmart. There has been large enough Hadoop data lake cluster where the data from all different places were getting sourced. It was obviously powered by a Hadoop cluster, where the default processing engine which were available, such as Hive, MapReduce, and Spark, they were working well to some extent, but even this data lake ecosystem powered by Hadoop has its own challenges. So one of which was it was becoming extremely cumbersome to source the data from different sources to get to a Hadoop lake. Even if you set up large pipelines, ETL pipelines, it's really a tough job with a growing volume of the data to ensure that all of that data reaches to Hadoop data lake cluster in time, because all the analysts will be waiting for data to reach to that place. So that was one challenging aspect. Second was most of this Hadoop data lake cluster are built from a bare metal machines. So and even though if you have a large enough cluster, it will always get challenged by the upcoming use cases. new volume being increasing beyond what you have already planned for. And we all know it's not easy to scale out the bare metal cluster. It's always a hell lot of things you have to do. You have to buy hardware machines, get a PO, do a racking, stacking. So usually scaling out on-prem cluster takes few days to a month's time. So these were two challenges that, getting data sourced into a data lake cluster, scalability of the existing cluster. Then we were looking at an acceleration solution. So that how can we find a query layer for which we can avoid copying data from different source systems to our Hadoop data lake cluster? And how about getting an acceleration or a query layer for which we don't get bogged by compute capacity of the data lake cluster? So that was the time we were evaluating different technologies, and we looked at Presto. Presto exactly does that. For a latter use case, it has an amazing separation of storage and compute. So we did a lot of pilot had a remote Presto cluster, not extremely remote, probably in the same zone where our data lake cluster are, but external remote Presto cluster, which were able to consume the data from the data lake Hadoop cluster. And we saw it was quite performant. It was, to some extent, the response time was far better than the existing Hive and Spark pipeline. So that gives us an acceleration layer which we can put in our stack, which will not get backed by the scalability aspect. And the other amazing feature which we were, when we looked at it, was the ability to do a federated query. So when we did analyze that anybody who wanted to query to generate their insights and reporting, they had to source all of the data to Hadoop data lake cluster. And many a times they are interested into a very fragment portion of the data, but they still tend to get the entire data set into a Hadoop data lake cluster. So we saw Presto already has a good federated engine where it can talk to and have ability to query the data without moving into Hadoop ecosystem. So it has already inbuilt connector for Cassandra, because we have a huge adoption on Teradata and Cassandra. And we saw that it was super easy for Presto to talk to Cassandra directly without moving that workloads into the Hadoop data lake. So for those reasons, we looked at, we did a pilot with one of our e-commerce team, we gave them this solution, which was they already had an BI integration tool which was talking to Hive and Spark through Looker. So we gave them a cluster where Looker was talking to Presto, and they were amazed by that. They not only reported a better response time, but even they were amazed by the ability of doing a federated query without movement of data. So now that was just one tenant. Then later on, we thought that how can we make it, available for all the different Walmart international businesses? How about we don't want to be in a position where we keep on going and spinning a different clusters for every different team. So we wanted to solve that problem. How do we leverage this technology and make an enterprise managed query service offering where teams or users just come in, they get onboarded, and they start querying the data and discover the data, all the different data sets which are across systems. So when we thought of building that enterprise query offering as a managed service, there are many things beyond just Presto which we have to build. We have to ensure that the authentication is taken care of. We have to ensure that security is not compromised. For the different level of sensitivity of the data, we need to ensure that there are strong role-based access control. So most of our authorization policies are residing in a component called Apache Ranger. So we have to ensure that we build security plugin which can talk to Ranger and do that thorough validation so we don't skip corner across the security. We have to ensure for sensitivity of the data that it supports encryption over the wire and encryption at rest. Then other non-functional requirements that have a robust monitoring in place to ensure that the teams which requires dedicated SLA can have, we can provision that in the managed query service. So with this requirement, we were able to build that managed query service offering leveraging Presto initially. And it was pretty amazing. So when the team looked at it, now they don't have to send a capacity request. They don't have to log into any edge nodes. They can have their existing BI tools talk to this query service directly. Maybe they have existing query services framework. They can just swap and use this query service and can do a seamless migration. So this is our initial architectural component, what it looks like. As I mentioned, we started off with a large multi-tenant Presto cluster, which was configured with the connectors we support. So there were connectors for definitely Hive. In on-prem, it was Hive over HDFS, and GCS, it was Hive backed by GCS tables. Then there were a bunch of other connectors. We had included mostly the SQL databases, Oracle, MySQL, then Cassandra. A lot of team uses a Kafka connector as well to do an operational analytics of how their Kafka pipelines are going on. All of that, they were able to do that with one unified, and the best thing, one of the feedback we got is the one SQL language they have to write. So as and when we keep adding connector, they don't have to have a pain to go and learn different technology. It's the one ANSI SQL language, and which will do the job for them. And there are a lot of the analysts who have been used to of leveraging BI tool where they are not used to of writing any SQLs as well. So if you know tools like Looker and BI, you can just connect to your data sources, and you can just do a slice and dice without writing any queries. The amazing part was Presto already had an integration with this. These BI tools were able to write Presto queries, so that had been also a seamless migration. There are a bunch of things you would require to make it at an enterprise grade offering. Apart from authentication and authorization, you want to ensure that you don't provision this cluster with something, service ID, which have access to everything. So there are additional things you would want to take a look at where, especially in on-prem or a Hadoop cluster, you enable impersonation so that this clusters run with services which can impersonate user, than giving this service account all the accesses possible, which could be compromising security. On quota, to provision dedicated quota, Presto already had some mechanism of resource queue, which we leveraged that. To ensure so when we observed our workloads has been widespread, as Presto is used for a generic query layer. So there were uses has been a finer lower level query to a minor level ETL jobs as well. So we do provide them an ability for individual teams to configure their query configuration separately with a mechanism of session managers. And our offering, which was in cloud, we have to be very cognizant of cost. So what we had developed is we actually written a lower level auto-scaling model, which ensures that our cluster get auto-scaled based on the load average increases. When the concurrency of queries increases, there are more queued queries. So that in that way, the clusters, our cluster which runs in GCP, get auto-scaled from as low as 80 machines to 600, 700 machines, depending on the workload. So we can curb the cost and keeping the cluster utilization high. Even with this offering, we observed few of the things what as the fundamental of Presto, which is a good thing, which it says that it gives you separation of storage and compute, which comes with the problem. Sometimes this separation makes Presto for every little query and every recurrent query to pull the data from the source again. And that even in on-prem or in cloud where your data is sitting over object storage, the prominent thing what Presto needs is a higher network I/O. So, and if you see that network I/O is something which you can never cap and guarantee. There are always, even in cloud, there are always issues of like noisy neighbors. There are some other applications which are choking bandwidth, which will, due to which you will not have a predictable network I/O, and which was reflected in the query performance as well. So we had done some analysis and we looked at it that we scheduled one query across a days. The same query had a very choppy performance response time, and it was all because of the network I/O. And we wanted to tackle that problem because you don't want to have response time were very flaky. Sometimes the same query comes back in 2 seconds, and at times it takes like more than 15, 20 seconds because of the network I/O. And then other thing we looked at is most of our analytical data was modeled in star schema because our analytical data sets have some slowly changing dimensions of type 2 where they cannot actually form a denormalized pre-join table. So when we looked at in the star schema model, when we analyze how different query patterns, the dimension tables are heavily used again and again. And we saw an opportunity where every time a query runs, it has to go and fetch the dimension table all over again, which are frequently used. So that was the time we looked at a solution of which can obviously cache this level of data to elevate the network I/O, and even queries which are frequently running over some data set can leverage this cache as well. And when we looked at it, there aren't many solutions out there in the market, even in the industry, in the open source community. Alluxio was the most prominent one. We did some quick evaluations, and the first one, it is highlighted there. When we have Presto co-located with Alluxio, it significantly reduces the network I/O. So definitely, we get a consistent throughput when we have Presto with Alluxio, so that every query, if the data of subsequent queries are cached, it can elevate going to that unpredictable network I/O. And secondly, when we have an Alluxio-based cache, when we had a finite in-memory cache pool, we also tried pinning specific dimensions data sets which are being used frequently. So that also gave a significant performance boost in the query workload which was leveraging this star schema-based dimension model. Even otherwise, when we did an initial benchmarking for a certain workloads, having an Alluxio caching along with Presto gave a significant improvement up to 18 to 25%. But one of the things which we saw that especially not the larger OLAP queries, there are smaller queries to a moderate queries which there are a large number of queries running concurrently. Having Alluxio cache enabled gives us a much higher concurrency because it elevates the fact that all different workers again has to go and pull the same data back from the network. So those are initial findings, eluded that we incorporated Alluxio in our stack, even in our managed query offering. Though we did not auto-scale Alluxio cluster, but we ensure that a finite memory pool is always present in the stack, which can give us all of this benefit. So with that alteration, our stack looked like this. So we had Presto cluster as before. We had co-located Alluxio clusters, which when Presto and Alluxio were Presto Instead of talking to an underlying GCS directly, talking with Alluxio file system. So whenever it could find data in the cache, it was loading from the cache. Whenever it not, it was Alluxio was taking and filling up the cache for the subsequent queries to improve the performance. Rest all things remain same as per the architectural components, same authentication, authorization plugin, same. There is one thing which, if you have a table, Hive table, which is mapped to a GCS, and if you want to enable Alluxio cache, there is some pre-work you have to do. You have to create that table, first create an Alluxio mount point of where the data is located, and then you have to switch that table to say, instead of pointing to a GCS back table, you have to mention that now it is pointing to Alluxio FS. Now, since it's a managed query service offering, it is giving an exposure to thousands of tables. We didn't want our users to, hey, if you want to use Alluxio, go and create these 2 steps. That wasn't going to work. So we had to implement certain autosync mechanism that every tables which are listed in our Hive Metascore, we automatically go and create Alluxio mounting. So this is where this component came into a picture. So unfortunately, what I'm aware that there's no auto-syncing of this. This would be a nice-to-have feature in the Alluxio stack as well. But if it wasn't there, we had to build that where it actually, and callback hooks which keep looking at the new tables and the alteration in the existing Hive tables. Whenever there are new tables, this component will go and create Alluxio mount points and create a table, swap that table from, instead of being a GCS back, to an Alluxio back. So whenever users and teams query data sets from our stack, they're actually, they don't even realize that it is not a Hive table backed by GCS, it is a Hive table backed by Alluxio layer. After some time, when we have been running in public clouds for quite some time, and we faced with some challenges. There are always some teams which, due to some compliance issues, because of their data sets are highly sensitive, they couldn't move their workload to the cloud. And there was a lot of requests that they wanted to have this acceleration layer power their workload as well. And they wanted to have use this query service, and even for burst workloads to get access to this query layer in the cloud as well. So now there was a time where we had to actually bridge that. So when we have our offering, which is Presto Alluxio cluster, which is running in cloud, and how can it will go and fetch the data which is in on-prem. So functionally, we can do that. There was even a good enough pipe, which is again not it's a shared pipe which is used across different. There are always ETL jobs which are choking most of the bandwidth, which is transferring this data from on-prem to cloud. So even though that pipe is there, we wanted to ensure that, hey, how can we enable a functionality where this query layer can go query data sets which are actually reside in on-prem cluster. So when we did that, again, we saw that it is unpredictable network I/O is not giving a good response time when they try to query the data in on-prem. So that is where also when we have, for those specific data set, we actually pin those data sets in the Alluxio cache, and which again greatly improved whenever those data sets is queried. So now Alluxio is acting as a data orchestration or a storage layer. Whenever that on-prem data sets are queried, they are getting cached into an Alluxio layer in the public cloud, so which will help and boost query performance for the subsequent queries. And it was critical and important that there was a reason for the compliance reason. Those teams were not supposed to move those data sets there. So enabling this pipeline was easy, but we had to ensure that we don't make that break that compliance trail, and people shouldn't start exploiting this layer by transferring this data to public clouds altogether. So we had to implement a lot many safeguards, and apparently the way Presto is extremely configurable and extensible to do that. So it has mechanism to implement lot many interceptor where you can go and tap that, hey, which particular data sets you want the queries, schemas and tables you want the queries to be allowed, which particular data set you didn't allow. So we built a lot of those safeguards that highly sensitive data sets were, even if been queried from cloud, we did not allow and write back functionality. So they should be able to just query it. So they'll not be able to write back or do a create table as or insert into. So such interceptors and plugin which we write into Presto to ensure that those layer does not get exploited to move this data set directly to the public cloud. And even to ensure that people shouldn't use this query layer to ingest the data from on-prem to a query layer. So this was one of our use case which highlighted when we were running in the hybrid cloud mechanism. Now the next week, we are getting into a place where we are landing into a multi-cloud zone where, as of now, even today Walmart is extensively using 2 public clouds, and we will be rolling out, and in a situation that we have to provide this acceleration layer across these public clouds, and even provision and source the data set from on-prem as well. So that would be an interesting problem, since even if it is 3 different environments across multi-cloud environments with on-prem, I think it is super critical to have a caching layer which can emulate the data. Otherwise, it will be for every single query going across to multiple clouds or to on-prem getting all of data. It will be a huge utilization of the network bandwidth. And even to some extent, Alluxio greatly help is that there are some tables and data sets where you wouldn't want to just create copies in public cloud. So once you have those pinned, and when you have tables which are pointing to the similar data sets in on-prem, Alluxio takes care of syncing the data. Even if there is a data or metadata changes, Alluxio syncs that. So that will elevate you from making copies of those data set again back in the public cloud. So overall, this is how we tackle the acceleration query problems by using Presto and Alluxio efficiently. So we ensure that all of the data is put to work. We give them an solution where they can do a federated query, which is not only across data sources, even with the caching enabled, they are able to do it across environments as well, on-prem and cloud as well. Teams were very happy, even with the teams of data engineers, that now the standout feature is they don't have to go and talk to every source in their native language. That was one SQL, ANSI single language. They just have to learn once, and then they can talk to all the different source system by leveraging that query language. Definitely, there were, I've seen testimonials, and there were a lot of teams reached out to us and say that they received a huge performance gain in response time once they moved here. There are teams where they have claimed that their response time is increased by 20x when they move to this acceleration layer. So that both of this is possible because of Presto as an amazing MPP engine and Alluxio as a nice caching layer in between. as per the managed services, this offering, even it is hugely benefited to users and teams who just want to do a very canned reporting on ad hoc analysis where they don't have to spin up large enough cluster. We do have a mechanism where it's not an infinite clustered resources. So we do have a mechanism where we tap into and audit every single query which is run by every user, how much of data that query has crunched. And we have a cost attribution of that, since we have a component which looks and tap into how much of resources were used by cumulatively across users, and then we have a cost attribution mechanism which generates a chargeback report, which we go and then bill to the individual domain teams. And yes, so the operability has been increased, and Presto's integration with most of the BI tools have made things super easy. As far as the adoption, I know that the heavy analyst users have been leveraging Tableau and Looker. There are a lot of data scientists have been using this acceleration layer from their RStudio. A lot of data engineers use, we also give them a BI tool called Superset. And there are a lot of people use it through notebooks like Jupyter and Zeppelin. So in that ways, it really greatly helped where Presto has already a pre-built configuration with those BI tools. So that's pretty much it, Ruja.